Hey, algebra students, welcome to your intro to today's lesson. The success criteria for today is I can factor completely. So here's the thing, we've had lots of practice with factoring the last few weeks, but now we're adding another step to it. Make sure you have your paper and your pencil so you can take some notes down while we go through this. When you are done with today's video and you have your notes down, then you want to move into the IXL practice lesson for today, in which you are going to spend about 20 minutes working through some different problems to practice what you've learned. All right. So today, if we were at school together, we would be completing this lesson right here, which is lesson 814. All right. And in this lesson today, we would learn about what it means for something to be factored completely. We would start by doing 835 as a class, and we would go through each one of these problems, and you would see and you would practice just like what we've done before. And you would get to a point where you're like, all right, A, B, and C, we've got this. But then we would get to part D, and you would realize that, hey, maybe your team doesn't have the same answer as a team sitting next to you. We would have a discussion about why that is. And really, it comes down to this. If we look at problems that we want to factor, and in those problems that we want to factor, there is a greatest common factor that can be pulled out of that equation, we need to do that first. Otherwise, we can factor it, but it won't be factored completely because there's one more step to go before it's simplified. It's kind of like if you have a fraction, let's say 6/12, and you say, all right, let's simplify that fraction, and you tell me 6/12 simplified is 3/6. Well, that's true. It's not simplified completely because you could still factor it more. It's not in simplest form until you get to 1/2. So while we can factor 3n squared plus 9n plus 6 and come up with different answers, it's not in the simplest form until we pull that greatest common factor out. Okay, so if you look at part C here, it says without factoring, predict which quadratic expressions below may have more than one factored form. Well, if I'm looking at these, it's any one that has a greatest common factor in all three terms, not just one. It has to happen in all three terms. So for part 1, I have 12t squared minus 10t plus 2. Well, 2 is a greatest common factor in each one of those terms, so I can pull it out of that first, then simplify the quadratic, and then factor. Kind of confusing when you can't see it. So how about we do this? I'm going to demonstrate how to do, I forgot what number this is. This is 38A. All right, 38A. So I'm going to demonstrate how to do that over here on Sketchpad so you can actually see me work through this. So if I'm looking at this problem right here, I have 5x squared plus 15x minus 20. So from now on, the first step you need to ask yourself when factoring quadratics is there a greatest common factor that can be pulled out of each one of these terms? And the answer to that question for this one is, yeah, there is, because 5x squared can be divided by 5, so can 15x can be divided by 5, and so can 20. So what I'm going to do is I'm going to divide my entire expression by 5. And what it's going to look like is this. 5 is going to go on the outside of my new quadratic. And then I'm going to put everything else in parentheses. Okay, so if I take 5x squared and divide it by 5, I'm left with x squared. If I take 15x and divide it by 5, I'm left with 3x. And if I take 20 and divide it by 5, I'm left with, and I'm keeping the subtraction, be careful of signs, it stays negative, I'm left with 4. So now the quadratic that I'm going to factor is right here. It is the x squared plus 3x minus 4. That 5, we're going to worry about that guy later because he is going to be a part of your final answer, but not until the end. Okay, so now we're going to go and we're going to use our generic rectangle and we're going to factor like we've learned to do. X squared, and then I have minus 4. Negative 4 times x squared is negative 4. X squared goes up here, and 3x goes down there. Now you're going to think to yourself, I need factors that multiply together to be negative 4x squared, but add together to be a positive 3x. So that usually tells me that I'm going to have one of my factors be positive and one be negative. That's the only way it will work to get them to multiply to be a negative and add together to be a positive. So there's not many factors of 4. It's either 4 and 1 or 2 and 2. So in this case, if I have a positive 4x times a negative x or negative 1x, however you want to write it, I always want to double check yourself. 4x times negative x is negative 4x squared. 4x plus negative x is positive 3x, so it works. I'm going to go and fill in my generic rectangle. Oopsie, that was supposed to be a negative x there, not a negative 4x. We're just going to write over that because this is kind of annoying when you have to erase. So I'm going to put negative x there. I'm going to put 4x here, keeping in mind it doesn't matter, guys, if you switch them around. Greatest common factors I'm going to pull out, and I'm going to have to move this around. Will it let me? Oh, good. It'll let me move that up there, so then that way I can still write below it. I'm going to pull an x out here because x squared and 4x, greatest common factor, is x. X times x is x squared. X times negative 1 is negative x, and x times 4 is 4x. Now, I did that really quickly because this part should be review, all right? The new stuff is, what do we do with our greatest common factor? Well, we still write this binomial as x minus 1 times, sorry, my hand's in front of the, x plus 4, all right? But that's not our final answer because guess what? That greatest common factor that you pulled out over here, oopsie, I circled it and it disappeared. Weird. I'm learning new things about this all the time. That greatest common factor, that 5 that we divided out, you got to take that 5. Oh, I'm doing real funky things. And you have to put that 5 on the outside of your answer because it's like saying 5 times x minus 1 times x plus 4. So guys, to factor this, oh, I cannot circle apparently. It does not let me circle. Even though I like circle answers, it won't let me. It erases things. I guess that's how I erase things. So to factor 5x squared plus 15x minus 20, you pull that 5 out, that greatest common factor goes on the outside. So then you have 5 times x minus 1, x plus 4. This right here is your final answer. And you could double check that by going ahead and multiplying the binomial together again, x squared minus x plus 4x minus 4, adding them together, and then multiplying each term by 5, and you're going to end up with the answer that you started with, okay? So that's how you factor completely. That added step today is pulling out that greatest common factor, factoring what you have left, but remembering to put that greatest common factor in your final answer. Because historically, when kids lose points for factoring, it's because they're not carrying that greatest common factor they divided out through. All right, so you need to make sure that that 5, that greatest common factor, is in your final answer. Hey, if this is super confusing or if you have questions, make sure you reach out to either me or Miss Green via email or join us for a Google Meet call this week, and we will help you wherever we can. If you're feeling pretty good about this and you want to practice, head on over to the IXL link right now and practice. Give it a good 20 minutes. Get through a few of these to make sure that you really have a good understanding of this. This is the stuff that's going to be on your quiz on Friday. All right? Hey, have a great day. Talk to you soon.